Okay, the question we have here, the bacteria in a 15-liter container triple every 5 minutes. After 40 minutes, the container is full. How long did it take to fill a third of the container? So the first thing that we need to do is to get the model that we're going to be using for this particular problem, and the model from our book is A equals A0 e to the kt. And just to explain what the various parts are, A is the amount of bacteria that's present at any time. So that's actually how much bacteria is there, and that's measured in liters in this particular problem. And the next one, A0, that's how much bacteria is present initially, in other words at time 0. So how much bacteria that you start off with. So we'll need to figure out what that is to be able to work this problem. K is the growth rate of the bacteria, so that kind of tells you how much the bacteria is going up or down. In this case it's increasing, so it kind of has a description of that. And T is the time, and in this particular problem it's measured in minutes. So the first thing that we need to do before we can answer the main question is we need to figure out what A0 and what K are. Okay. So first off, let's take a look and see if we can figure out what K is. Remember, K is the growth rate of the bacteria. So looking through the problem, there's this sentence in there. It says the bacteria triple every 5 minutes. So that sentence there is describing how the bacteria is growing. So that's going to let you figure out what K is. So looking at our model, right now we have A equals A0 e to the kt. So it says the bacteria triple every 5 minutes. So triple, we don't know how much we started with. That's A0, but if that's going to triple, it's going to be 3 times A0. So 3 times A0 we'll take and we'll plug that in for A. And then we'll plug 5 in for T, since it says every 5 minutes. So after 5 minutes, however much you started with, you're going to have 3 times that amount. And so that gives us an equation that we can solve for K. Okay, so there's our equation. We want to solve for K, and notice it's up in the exponent part there. So we're going to have to use logarithms to solve for it. That's the inverse function for the exponential function e. So before we do that, though, what we would do is try to get the exponential function by itself on one side, and we can divide both sides by A0, and that will give us 3 equals e to the 5k. And now the exponential part of the function is by itself over on one side. And so once we have that, then we can take the natural log of both sides, and over on the right hand side, natural log of e to the 5k. That will cancel out there and leave us with 5k equals natural log of 3. Since natural log ln and the exponential function e, they're inverses of each other, so they undo each other and you're left with just the exponent part. So now that the exponent part is down where we can solve for k, we can just simply divide both sides of that equation by 5, and that will get k by itself on one side. K equals natural log of 3 divided by 5. You can either take that and plug it back in for k, that expression itself. I'm just going to approximate it. It's approximately 2.197. Just make sure that you take enough decimal places there. Don't round off too soon. So in the long run, you'll get better results if you take that exact expression, ln 3 over 5. That's what I'm used to doing, but just to explain things, it's a little bit easier if I just go ahead and round off. So, alright, so I'm going to take that value, and now I know what k is. I plug it back into my model, or my equation, in the right spot there, 0.2197. So, alright, so next up we want to find what A0 is. we're going to use, looking through the original problem, it says after 40 minutes the container is full. So that means after 40 minutes the container is full, and it was a 15 liter container. So the amount will be 15, so we'll plug 15 in for A there. And the time that happened was 40 minutes, so we'll plug 40 in for T. And you can see that leaves us an equation with just A0 in there, so we can solve for A0. Okay, so there's, I just multiplied 40 times K there, got 8.788. And so now to solve for A0, all I really have to do is divide both sides by e to the 8.788 there on both sides. And I wind up with A0 is 15 divided by e to the 8.788. And so A0 is approximately 0.00229. So, and that's how much bacteria that you would have initially there. So now you know what A0 and K are. Take that and plug them both back into your model, and so now your model is good to go. You have the two variables in there, A and T, and so now we're finally ready to answer the main question of the problem, which was how long will it take to fill up a third of the container. Okay, so notice there they're asking us how long, right? So they're asking us for the time T. So we'll be solving for T here, and so they'll have to tell us what the value for A is, and that will be a third of the container. So a third of the container, we will plug 1/3 times 15. 15 was the whole container in for A, and then we'll solve that equation for T. Alright, so 1/3 times 15 is 5, and just simplifying a little bit there. And again, this is an exponential function, so I want to divide both sides to get that exponential function by itself on one side there. So, alright, so I wind up with 5 divided by that A0 is 2,183.406, and now you can see on the right hand side of the equation I have E by itself there. So now use the logarithm function to take the log of both sides, and on the right hand side the log function and the exponential function are going to cancel each other out, leaving me with just the exponent there, 0.2197t. Okay, and so now the last step would be to divide both sides by the number with t there, and so we wind up with t equals the natural log of 2,183.406 divided by 2.2197. And so if you plug that into your calculator and just rounding to the nearest whole number, it comes out to be 35 minutes.